Okay, it is the second example for signed rank test. Now we have 15, the 15 sample. It is the pH level for the 15 lakes. And we want to test if the lakes are non-acidic. Non-acidic means the pH is higher than 6. I can see somewhere the definition of the non-acidic. Yeah, it's a non-acidic is a pH is greater than 6, then we can say it is a non-acidic. So the alternative hypothesis is greater than 6, so that will be the right field. Okay, let's try. So here is a table, and we have 15 samples here. And now we subtract the 6 because of the hypothesis in step number 1. And now we take the absolute value of the difference. Then now we can rank the differences. I think the 0.1 is the smallest one, so it is the rank number 1. And the second one is a 0.2. And the next one must be 0.3. But the problem is now we have 3 kinds of, it's a 0.3. So now we have ties, the 3 ties. But one of them must be rank 3, 4, 5. But they are ties. So we can take the average. So we can take the average of the 3 ranks, 3, 4, 5. That would be 4. So we assign the rank 4 for the ties. And the next one is the, let me see, it's a rank 5, 6. And the next one must be rank 6. The rank 6 for 0.5, I'm sorry, it's a rank 6 for 0.5, but we have, it's a 2.5s. But the rank must be, one of them is a 6 and the other one is a 7. Then now we can take the average again. So the 2 ranks should be same as 6.5 and 6.5. And the next rank is must be 8 for 0.6. But now we have only 1.6. So it is a single rank 8. And 0.7 is a 9. Do we have a 0.8? No 0.8, but we have a 0.9. 0.9 here and another 0.9 there. They must be rank 10 and 11, right? So take the average, it must be is a 10.5 and 10.5 for the ties. And the next one must be the rank 12 for 1.2. And the next one is a the rank 13 for 1.3, and here is a one more 1.3. So one of them is must be rank 13, 14. So the average will be 13.5 and 13.5. And the next rank should be the 15 is the biggest one. 1.9 is a 15. So we assign the rank from 1 to 15 because it's actually we had 15 observations, but as many of them are ties, then we just assign the rank is 1 by 1 and we just take the average. And now at the end we need a signed rank, but we had only 3 negatives. So that will be negative 6.5 and negative is a point. I'm sorry. We need the signed rank. So it must be negative 6.5 and negative 4 and negative 2. So they are the signed rank, the negative one, and the others is a positive. It's a 12, 13.5, 1, 10.5, 8, 13.5, and 4. and 4 again, 6.5, 10.5, and 9, and 15. Now we need the test statistic. So now here is a step number 1, the hypothesis. And the second one, we need a test statistic, the W. It is a sum of the positive ranks, the black one. Let me give you a tip. You know, when I add from 1 to 15, even though we got ties, so we assign the ranks, we assign the average ranks, so it doesn't matter. When I take the sum up, the all ranks from 1 to 15, the sum of the rank is 15 times 15 plus 1 over 2. So that will be 112. So now we need the sum of the positives. It's a sum of the rank is positives, but I can say even I just count the sum of the negative ranks and the positive ranks is together, that will be 120. So when I take the sum of the negative ranks, that will be negative is 12 is 0.5. So I can say we need the test statistic, the positive ranks, plus 12.5, that must be 120. So simply I can take the so now I just take the sum of the positive, that is minus 12.5 and minus 12.5. So it will be let's cancel out. It's 120 minus 12.5, that will be 107.5. Absolutely, you just take the sum up. You just take the sum up the positive ranks, then absolutely you will get the same answer. The same answer as 107.5. And now next, we need the critical value, that is the W alpha. Alpha, let me say, is 0.05. So let me go to the W table here, right? And now we have it's alpha is 0.05, and the sample size is 15, and there is a 90. So let me go back to the distribution. The distribution here, yeah, is roughly is symmetrical, and the maximum possible value, the maximum possible value of the sum ranks, that is 120, and can be 0. The positive one, right? And the critical value is 90. And we had the right tail. We had the right tail. So when we have a test statistic in this range, then we can reject the null hypothesis. And absolutely, it is here. It's a 107.5. So the decision would be reject the null hypothesis. We just take the critical value from the table. It's a 90 directly because we had the right tail, but before we had the left tail, then we did is 120 minus 90 to get the left tail. But now it was the right tail, so we just take the as bigger than 90, then we reject the null hypothesis. So the conclusion will be it's based on the alternative hypothesis, which was the pH is higher than 6. What does it mean? The lakes are non-exceeded. It's a number 5. Step 5, the conclusion. So it is the second example, but it has lots of the ties, and it was the right-tailed.